Good morning. I'm Hugh Harris at the Kennedy Space Center, and we're here for a briefing on the status of Challenger and the flight readiness firing, which is presently scheduled for 11 a.m. Eastern Standard Time tomorrow morning. And with us is Al O'Hara, who is the Director of Launch and Landing Operations. Al?
Okay, thank you. Good morning. As Hugh said, our schedule is to get to a T0 tomorrow morning at 11 o'clock for the first firing of the engines. What I plan to do is sort of review the activities between now and tomorrow morning for you, and maybe review the schedule as to where we're at and where we plan to go, and discuss with you the post-FRF activities that will be taking place in the next few days. At 12 noon Eastern Time today, we'll go into a 10-hour, 40-minute hold. And that will be culminated in the retraction of the RSS from the orbiter. Tonight, about 10:40 p.m., we'll start the rotation of the RSS. And after that's complete, we'll start our terminal count. The countdown is very similar to a launch countdown. You'll see a lot of similarities there. We have a 1-hour hold at T-minus 3 hours. We have a 10-minute hold at T-minus 20 minutes, and we have another 10-minute hold at T-minus 9. All aiming toward a T0 tomorrow morning at 11 a.m. Now let me review quickly for you the objectives of the flight readiness firing. The primary objective is to check the shuttle vehicle integrity and the performance of the main propulsion system. That includes the orbiter systems, the ET, and the Space Shuttle main engines, the SSMEs. We have some secondary objectives. One is to verify the combination of the launch facility. You know, this is a new mobile launcher. We've not fired off of this on the Space Shuttle before. And we'll test the total system as we fire the engines. We'll establish any baseline that we might need for the future as far as any minor leakage of the hydrogen system in the aft compartment. This baselining is necessary to know whether or not we've got a significant problem on future launches. And we will determine what we call the twang of the vehicle. When the SSMEs ignite, the vehicle has a tendency to tip toward the north, so we'll assure ourselves that the twang response of the stack is as predicted, and that in turn determines when the SRBs rather, are ignited for launch. But we don't expect to have any change in that timing sequence as a result of the test. And of course, we'll be checking the APUs. They will be fired tomorrow on the orbiter, the auxiliary system there, and we'll check the hydraulics and the flight control systems. So that, in a nutshell, is the primary objective, and the secondary objectives of the test tomorrow. The main engines will ignite as they would on launch day at T-minus 6.8 seconds, and they plan to go up to 100% thrust and stay there for approximately 20 seconds. The first engine 1, will cut off at 18.2, and the second and third engines will cut off at 23.8 seconds. Now on the clock, you'll see that a little bit earlier because remember it does start 6.8 seconds prior to T0. Now after the test is completed, we'll do an extensive review of the data, and we'll have an on-net briefing about 30 minutes after the firing to pulse our people to see if we have any real-time anomalies that have been noted. At that point in time, we'll get into the data review. That takes about 48 hours. So sometime Monday, around Monday noon, we'll know whether or not the data looks good. We'll then go into the actual physical inspection of the engines, and that will begin as we start building up access. And we expect to have the two most important checks completed by Wednesday noon. And that is the torquing of the high-speed turbo pumps. We torque those to make sure that we haven't had any degradation in those pumps. And we'll also do some other inspections that are very critical. We have to look at some turbine blades to make sure that there hasn't been any erosion on those blades. We expect that activity to be complete by Wednesday noon. At that point in time, we'll have high confidence in our scheduling and in our program from that point to launch. Now, if all goes well on Saturday, next week, we will run a portion of our dynamic testing that we had scheduled for the VAB that we deferred to the pad. We'll complete that on Wednesday. And the plan right now is for the cargo, the TDRS IUS cargo, to go to the pad on Monday the 27th of December, and they will be doing standalone testing in the PCR for that week. We'll return from the Christmas holidays on the 2nd of January and begin our preparation for the hyperloading of the TDRS spacecraft. That will take place on Monday the 3rd. And from that point on, we'll have a Delta crew equipment stowage exercise, interface test, and that is scheduled for the 8th of January, and our terminal count demonstration test, which is a test, the old countdown demonstration test where we establish our timelines. The crew will be here and participate in that. That test is scheduled for T0 of January 10th. Now, the launch date will not be set by Washington until we have a successful FRF and we're able to get in and do the final inspection on the engines. So that, I can't tell you what the launch date will be because it'll be determined probably in the Wednesday time frame. I expect the launch would be no earlier than the 27th of January because we've laid out our schedule between now and then, and so I'd expect it would be no earlier than that, but the actual launch date will be established by Washington later next week. Hugh, I guess that sort of is a summary of where we're at and where we're headed.
Great, thank you. We're ready for questions then. Are there any questions here at Kennedy before we go to other centers? Peter Adams from Today newspaper.
Yes, Mr. O'Hara, you said that if all goes well next week, there'll be, I believe you said, dynetics test?
The shuttle interface test, SIT test, DIT's a portion of that, and we plan to run that Wednesday. That was deferred from the VAB.
Thank you.
We'll do that in parallel with doing our engine checks.
Mary Bob.
Two things. He said it was going to be minus 6.8 seconds up to. Do you start counting the 20 seconds at that point? I was a little confused.
The 20-second time is the time that the engines will be operating at 100% of thrust. So we will ignite them at minus 6.8, and there's a build-up period of time, and then we'll run them for about 20 seconds, and then they'll cut off.
And these are higher rated, aren't they, than the Columbia ones?
Yes, but we'll be firing them at 100% of rated load tomorrow.
So you won't be firing them at. They're more powerful than the others, though, aren't they?
Yes, but we won't be firing them at the top level. They have been tested at that level, but for tomorrow's test, they'll be at the 100% level.
How much more powerful are they than the others?
I can't give you a number in thrust. 107% is a rated thrust on these. They have been tested at that, and if we got into a situation where we needed additional thrust because of a transatlantic abort, that capability does exist. But for the firing tomorrow, we don't plan to go that high.
Harry Kokum from Aviation Week. Wait for the mic, Harry.
That 104% I thought was going to be a test tomorrow.
Tomorrow? No, 100%.
What do you have on the top of your head the amount of twang that has been experienced in the a range of twang in the first 5 launches?
Range of twang. You mean the number of inches it might? I don't have that at my fingertip. It's very small, 2 inches to something like that, in a very small amount. But it's important to, the purpose of that is if when the engines ignite and it tips over, you want to wait for the whole stack to get back to a null position before the SRBs are ignited, and that's the purpose of the test, is to determine when to ignite the SRBs. And again, we don't expect the stack to be any different than we had with Columbia, so the ignition time should be the same.
Rob Zaya.
Generally speaking, how does this FRF compare to the one that you had for Columbia? And what condition are the engines for the Challenger in right now?
Well, the engines are in great shape. We have no concerns about them at all. We don't plan to gimbal the engines on this test like we did for STS-1. There's a different kind of profile. There is no need to do so. We don't plan to run the SRB HPUs this time like we did before because they have already been tested as a part of the aft skirt previous to stacking. So there's a whole list of differences that would be pages long between the two. But this is a test that we feel is adequate to get the margin we want, to feel good about the engines, and we have no problem. We were very optimistic. I might also say about the schedule, I personally did not feel we would be at this point this December. In September, October, November timeframe, I was very pessimistic about being able to get there. So we're sort of, we push people quite hard. A lot of people spend a lot of time. It's been a 3-shift, 7-day effort to get to this point in time. So we're happy to get it off before Christmas, and we'd be very disappointed if anything happened that caused us to not to fire tomorrow or Sunday or Monday. We will, if for whatever reason we can't get into the firing tomorrow, we will try to get it off before Christmas, but we're optimistic about it tomorrow. By the way, there are no hole or recycle constraints other than after we start the APUs. So if we get down to T-minus 5 minutes and have to hold, really the only kind of constraints we're worried about would be crew fatigue, and we'd like to do it during the daylight hours. So this morning we talked, and we're sort of arbitrarily looking at a 4 o'clock tomorrow afternoon cutoff. We would not go beyond that because of crew fatigue, and the night we like to get good camera coverage.
Gary Balinoff from Channel 6.
On the first launch, you had a problem with overpressurization after everything looked like it would work as planned. This time you have a lighter weight tank. You have a couple of solid rocket boosters that are weight savers. What kinds of things do you look for to make sure that that kind of problem doesn't happen with this first firing of the lighter weight tank?
Well, all of the data from the firing tomorrow will go up to Marshall, and some of it will go to JSC to be analyzed. I don't have a list of all of the instrumentation, but having had the experience of the first FRF and having all these firings under our belt, we understand the dynamics much better than we did at that point in time. So I personally, even tomorrow, let me say this, if tomorrow we get an early cutoff, if we don't run 20 seconds, that does not mean that we've had an unsuccessful firing. If the engines start up and run for a few seconds and get cut off for some reason other than the engines, we will assume that's a successful test, because a startup, getting up to 100% of thrust, getting a cutoff, and everything operating normally from that point of view is what we're looking for. So 20 seconds is not a magic number that we have to get to. We'd like to do that, but if it's cut off for some other reason at some point in time, that's acceptable to us. Even if it runs 6 or 7 seconds and cuts off for some other reason, we would have no problem with that.
Yeah, Jim Long from JLA.
Al, a couple of questions. Can you have a T0 any earlier than 11 a.m.?
No, we would not plan to move it up. We set that time as a good time, looking at crew cycling and so on. Our crews now are set up to do that, and we would not move that up.
What would the tank conditions be for, could you recycle, if you didn't go by 4 p.m. tomorrow, could you recycle for 24 hours?
Yes, we could. We have no problems on a 24-hour recycle. We can't foresee any problems that would cause us to go 48 hours, for example. We would go 24 hours. Of course, whatever the problem is would have to be fixed, and we don't know what that might be, but 24 hours is our objective.
Anticipate any software problems?
Don't anticipate any. That's a world that's only understood by a few, but we don't anticipate any problems. We've gone through really 3 simulations for the FRF. We ran 2. I've lost track. This is Friday.
Right.
Earlier in the week, we ran 2 FRF sim runs, and the purpose of that was to check the GLS system. And those tests were very successful. There were a few minor timing errors, as they were explained to me, that are of no concern to our software people. We don't intend to go back and fix any software for the test. So we've been through 2 sim runs. In the first run, we went recycled back to 20 and came down through again. So we have high confidence in the software for tomorrow's test.
Okay, are there any additional questions here? Peter Adams from Today.
Just one question about the physical inspection of the engines. Could you elaborate a little bit on what the engineers will be looking for specifically inside the engine? Will they actually crawl into the into the engine cavity?
We'll take the heat shield off, and we'll go up in there and actually torque the high pressure oxidizer and fuel pumps. We could give you a rundown of what we do. I don't think it'd be of great interest, but the primary goal for the test is a visual observation of all the hardware, an inspection of the nozzles to make sure that there's been no damage. We will go up with a borescope and look at the turbine and inspect that. That's about a 2-shift job. That's the long pole, so to speak, in the engine inspection effort. That's the one that will be complete about noon on Wednesday. It's just a general review and observation and internal inspection to assure ourselves that no bearings might have galled or any problems of that sort. The engines, of course, have been tested, and they're all flight worthy.
Okay, we're going to go to the Marshall Spacecraft Center for questions from there.
Dave Dooling, the Huntsville Times. Can you hear me now? Oh, come on now.
Barely. Say it again.
Dave Dooling, the Huntsville Times. Can you hear me now?
Yes, we can.
Okay, Al, will any of the booster systems other than the HPUs be activated and operating during the FRF?
No, the HPUs on the boosters will not be a part of the test tomorrow. The
Al,
SRBs are not participating in tomorrow's test from that viewpoint.
Okay, that was my question. Was booster systems other than the HPUs? The boosters in total will be deactivated for the test? No systems at all will be operating on the boosters during the test?
There will be some instrumentation, my understanding, that will be up and operating, but that's the extent of it. We do have the buses. The buses will be up, and we'll have power on the SRBs, but the engine, the thrusters will not be, TVCs will not be operating. We'll have power on the SRBs, yes.
Okay, now, did I understand you to say that even once you have the orbiter APUs operating, you could sit and hold until 4 p.m. on the FRF ignition?
Yes, we could go down to T-minus 5 minutes. That's the point that the APUs begin running. Okay, and we don't plan to reservice the APUs between now and launch. So we have a budget for tomorrow's test that we would like to stay within. We would like to stay within a 12-minute budget on the APUs, so we'll have adequate margin to go into the launch. So when the APUs start at T-minus 5 minutes, they'll run to T+2 minutes. That's a 7-minute margin tomorrow, 7-minute budget tomorrow. If we have a recycler or if we want to hold, we could go up to 12 minutes or so. It's not sacred. We can go back in and reservice and still make the launch. But that's the way we're going into the test tomorrow with that budget of the APUs.
Okay, and what are the differences between Challenger's flight systems and Columbia's flight systems that made NASA decide for an FRF on Challenger? As I recall, initially there was no FRF plan for Challenger.
That's correct. We did not have an FRF planned, and when upper management reviewed the plans, it was decided by the program that it would be a wise test to run on each new shuttle. And in fact, we were instructed last week for our planning purposes to plan an FRF on 103 and 104 as they come down the pike to gain confidence in the structure, to get the dynamic information that is useful for our people, and that is currently being baseline for all of them. It's a confidence test. It's not an acceptance test. It's just to gain confidence. At one point in time, we did not have the FRF baseline, as you said, and after management reviewed the recommendations of all the people, it was decided it would be a good thing to do, and we were asked to put it into flow. Now, as you remember, back in the July-August time frame, we had a January 20th launch date, I believe. That was the launch date we had back at that point in time. And when management asked us to factor in the flight readiness firing, our estimate at that time was that it would be about a week's impact. And after all said and done, that's basically what it's turning out to be. Our January 20th original launch date. The earliest date that we feel like we could support would be January 27th. So the schedule from July, August, September on down has been a good one. And we support the FRF firing. You know, we feel like it's a good test to run, and we're happy to plan it.
Will the flight crew be here? Excuse me, there?
Of course, the crew, it will not be manned tomorrow. There will be no one in the crew compartment. It isn't necessary to have anyone there, so there's no need to expose anybody to any unnecessary risk. I don't think they're going to be here with the firing. Hugh, I haven't heard, but I wouldn't expect them to be here.
Okay, and a final question. We saw the BSI people walk out after, just moments after the first FRF. Are there any labor issues outstanding as you go into this one?
Not to my knowledge. None at all.
No further questions from Marshall.
Okay, are there any additional questions here at Kennedy? Harry Colcom.
In developing your countdown, the last countdown lasted 100 hours, Al. Will there be any major changes between this one for the 6th flight and the last one for the 5th flight?
Harry, I haven't looked at the countdown bar chart. I would not expect many changes. If so, it would be because of the spacecraft requirements, but I have not reviewed the timeline on the countdown.
Any additional questions? Mary, Bob?
How much fuel will you put in the tank for this?
We'll be up to above flight mass on the ET. In other words, we'll load the external tank in the same fashion we would load it on launch day. The difference between this test and launch day is that we don't have to maintain a flight load. In other words, we can let the level go below what would be required on launch day, so we don't have that drain back problem that has constrained the window on launch day. You know, the last launch was constrained a bit by that, so tomorrow we won't have that problem. The only concern that we'll have tomorrow is if we're holding there for, say, 30 or 45 minutes and we get a lot of ullage space in there and have some problems with the pressurization, and then we may have to go back and recycle the T-minus 20 minutes and come down again. But that's the only concern we would have tomorrow. And also, Mary, you mentioned tile quite often. Let me report to you that we only have one tile missing on the orbiter, and we'll replace that after the firing tomorrow. And we also have an ET inspection plan tomorrow after we load. We'll let the debris team and the inspection team go in for an hour and a half or so to do a detailed inspection of the ET tank, and that's an important part of the test tomorrow.
Why are you filling them instead of just putting in enough fuel for the test?
Well, you have to meet, well, one of the things is to check the entire main propulsion system, which includes the total external tank and the engines and the orbiter system. So this will be, we want to make it as near a launch configuration as we can, first for the dynamics of the situation. In other words, the twang test I mentioned earlier, you want to have the total weight of it as similar to launch day as you can. And of course, propellants is a major contributor to the total weight. And also because of technical considerations of the LOX and hydrogen tanks, we don't want that.
We're going to Spencer Allen from CBS.
Alan, I was wondering on these tests, when you return the liquid fuel to the main tanks after the test, say you use 10% of the fuel in your tanks, how much wastage is there through leakage or through evaporation? Is it a wasteful process?
Well, you obviously use, a lot and do lose some. I don't have those figures. Our propulsion and propellants people could really give you that information better than I. Are you speaking about the losses of just going through the exercise?
In addition to the actual firing.
That number is available, but I do not have it at my fingertips.
Okay, if there's no additional questions, then for those of you who are going to be covering the flight readiness firing tomorrow, we'll open the Pass and Identification Building on State Route 3 at 7, and it will be open until 10:30 only. We feel that if you aren't here by 10:30, you're not going to get out here in time to see the launch. And if you have any, will be open until after the firing is over into the afternoon. I don't have an exact time, probably will be to about 4. We will have another post-firing briefing in this room 1 hour after launch with Mr. O'Hara. Okay, thank you all for coming.
APU configuration is complete, ready for APU start. T-minus 5 minutes, 30 seconds and counting. Onboard operational tape recorders have been turned on. They will record shuttle system performance during the test and be dumped after the test is complete for analysis. This is usually done by Mission Control in Houston, but for this test is being done from the firing room console. T-minus 5 minutes, 6 seconds and counting. Data acquisition cameras in the crew module have been turned on. T-minus 5 minutes. We have a GLS go for APU start, and we have APU start. APUs provide the pressure to the 3 orbiter hydraulic systems, which in turn are used to move the main engine nozzles and aero surfaces. T-minus 4 minutes, 40 seconds and counting. T-minus 4 minutes, 30 seconds. Main engine fuel valve heaters have been turned off in preparation for engine start. Auxiliary power units are up, looking very good. T-minus 4 minutes, purge sequence 4 has started. Final helium purge sequence on the main engine has begun in preparation for engine start. Launch pad film cameras have been activated. The aerosurface profile test started at T-minus 3 minutes, 55 seconds. All of the elevons, the body flaps, speed brake, and rudder are moved through a pre-programmed pattern. T-minus 3 minutes, 30 seconds. Shuttle going on internal power, still being supplied with ground reactants through the T0 umbilical. Vehicle will go on internal reactants at the T-minus 2 minute, 35 second mark. Main engine gimbal check has been initiated. Engine nozzles being run through a pre-programmed pattern at this time. T-minus 3 minutes and counting. T-minus 2 minutes, 55 seconds. External tank liquid pre-pressurization has started. Retraction of the gaseous oxygen vent arm was initiated at the T-minus 2 minute, 55 second point. This is the cap which fits over the external tank to prevent ice buildup on the oxygen vents. T-minus 2 minutes, 21 seconds and counting. Fuel cell ground supplies have been cut off. The fuel cells are now operating on internal reactants. T-minus 2 minutes, 15 seconds and counting. Main engines have been moved to the start position. T-minus 2 minutes and counting. T-minus 1 minute, 57 seconds. Liquid hydrogen replenish has been terminated. Pre-pressurization to flight level is underway. T-minus 1 minute 40 seconds and counting. T-minus 1 minute 30 seconds and counting. T-minus 1 minute 20 seconds and counting. T-minus 1 minute and counting. Firing system that releases the sound suppression water onto the pad has been armed. T-minus 50 seconds and counting. T-minus 45 seconds and counting. T-minus 40 seconds. SRB development flight recorders are being turned on. T-minus 37. Gaseous oxygen vent arm will not be retracted on this particular test. T-minus 31 seconds. We have a go from LPS for auto sequence start. 4 primary flight computers taking over main control of the terminal count. Final LPS command for engine start will occur at approximately T-minus 10 seconds. T-minus 15 seconds and counting. T-minus 10, go for main engine start. Hydrogen burn igniters are, we have engine start on the first main engine. 0, T-minus 0, engines throttled at 100%, all 3 engines up and burning. T plus 5 seconds, engine continuing to burn. T plus 10 seconds. 12. First cutoff, T-minus plus 15 seconds, engine cutoff, and engines 2 and 3 also cut off at T plus 16.8 seconds. T plus 25 seconds. GLS safing now in progress. We are continuing to run the APUs. We'll now turn them on to high speed for approximately a minute and a half high speed run. APU high speed is verified, T plus 45 seconds. T plus 1 minute. APUs continuing to run. They'll run for approximately the T plus 2 minute mark. T plus 1 minute 25 seconds. Continuing with the test of the orbiter auxiliary power units into the plus time. Verifying those units are go for flight. T plus 1 minute 45 seconds. T plus 2 minutes. The GLS critical safing has been completed. And we have shut down the all 3 of the orbiter auxiliary power units. This basically completes the flight readiness firing. There's still a number of hours of safing operations yet to be completed. We do have to drain the liquid oxygen, liquid hydrogen propellants out of the external tank. But other than that, the test appeared to have gone very successfully. The engines were run at the proper levels. Engine number 1 being cut off at 15 seconds. Engines 2 and 3 simultaneously being cut off at 16.8 seconds as planned. This was a major test in clearing the way for the 6th launch of the Space Shuttle. Still planning for a launch in late January. The time between now and its launch, there's still many work items that have to be accomplished, including the delivery and installation of Challenger's cargo in the orbiter's payload bay. The cargo is scheduled for delivery to the launch pad on the 27th of this month, right after the Christmas break. Will be installed in the orbiter's payload bay approximately 2 weeks later. Following some of the verification tests that accompany the insertion of the payload into the orbiter, they'll be ready to begin their final preparations for picking up the countdown and for launch. T-minus 15 seconds and counting. T-minus 10, go for main engine start. Hydrogen burn igniters are, we have engine start on the first main engine. 0, T-minus 0, engines throttled at 100%, all 3 engines up and burning. T plus 5 seconds, engine continuing to burn. T plus 10 seconds. 12. First cutoff, T-minus plus 15 seconds, engine cutoff, and engines 2 and 3 also cut off at T plus 16.8 seconds. T plus 25 seconds. GLS safing now in progress. We are continuing to run the APUs. We'll now turn them on to high speed for approximately a minute and a half high speed run. APU high speed is verified, T plus 45 seconds. T plus 1 minute. T minus 15 seconds and counting. T minus 10, go for main engine start. Hydrogen burn igniters are, we have engine start on the first main engine. 0, T minus 0, engines throttled at 100%, all 3 engines up and burning. T plus 5 seconds, engine continuing to burn. T plus 10 seconds. 12. First cutoff, T minus plus 15 seconds, engine cutoff, and engines 2 and 3 also cut off at T plus 16.8 seconds. T plus 25 seconds. GLS safing now in progress. We are continuing to run the APUs. We'll now turn them on to high speed for approximately a minute and a half high speed run. APU high speed is verified, T plus 45 seconds. T plus 1 minute. T minus 15 seconds and counting. T minus 10, go for main engine start. Hydrogen burn igniters are, we have engine start on the first main engine. 0, T minus 0, engines throttled at 100%, all 3 engines up and burning. T plus 5 seconds, engine continuing to burn. T plus 10 seconds. 12. First cutoff, T minus plus 15 seconds, engine cutoff, and engines 2 and 3 also cut off at T plus 16.8 seconds. T plus 25 seconds. GLS safing now in progress. We are continuing to run the APUs. We'll now turn them on to high speed for approximately a minute and a half high speed run. APU high speed is verified, T plus 45 seconds. T plus 1 minute. Final LPS command for engine start will occur at approximately T minus 10 seconds. T minus 15 seconds and counting. T minus 10, go for main engine start. Hydrogen burn igniters are, we have engine start on the first main engine. 0. T-minus 0. Engines throttled at 100%. All 3 engines up and burning. T plus 5 seconds. Engine continuing to burn. T plus 10 seconds. 12. First cutoff, T-minus plus 15 seconds. Engine cutoff. And engines 2 and 3 also cut off at T plus 16.8 seconds. T plus 25 seconds. GLS safing now in progress. We are continuing to run the APUs. We'll now turn them on to high speed for approximately a minute and a half high speed run. APU high speed is verified, T plus 45 seconds. T plus 1 minute. APUs continuing to run. They'll run for approximately the T plus 2 minute mark. T plus 1 minute, 25 seconds. Continuing with the test of the orbiter auxiliary power units into the plus time. Verifying those units are go for flight. T plus 1 minute, 45 seconds. T plus 2 minutes.
Good afternoon. I'm Hugh Harris at the Kennedy Space Center and like to welcome you to the post-flight readiness firing press briefing. And to tell you what happened today and answer all of your questions is Al O'Hara, who is the Director of Launch and Landing Operations for the Kennedy Space Center, and James Odom, who is the Deputy Manager for the Shuttle Project from the Marshall Space Flight Center. We'll begin with Al O'Hara.
Good afternoon. We're very happy to report to you that the flight readiness firing for the Challenger was successful and on time. And as far as we know at this moment, based upon the real-time data that we reviewed, the test looks like a resounding success. So I think we're in fine shape to move on in our processing toward a late January launch. Since we met yesterday morning, the countdown went rather well over the evening. We had a few minor GSE problems, but nothing of any significance. And we picked up the propellant loading for the FRF on schedule and got just a little bit behind in the LOX loading area because of some just red line changes we need to make and some things that were not fully understood before we went into the test, but they were very, very minor. We sent our ICE team in to do the inspection, and Jim will tell you probably a little more about that in just a moment. Everything looked great there, and the firing was on time. The engines ran the specified length of time and generated the amount of thrust we predicted, and the APUs ran well, had no problems to our knowledge. Now, again, let me caution you, this is based upon the real-time information from the firing room and from the support rooms that we got on the net about 30 minutes after T0. So as the day progresses and more information is available, that may change, but up to this point, everything looks great. So we're in the process now of getting ready to go in and inspect the engines, and as I told you yesterday, we'll have that inspection complete by Wednesday noon. So we're very happy with the test. It went very well. I thought the test team did well, and they're very happy to have this test out of the way before Christmas. That was our goal back in October, so we're very happy to have that milestone met. So Hugh, I guess we turn over to Jim and let Jim tell us what you might see from the Marshall point of view.
Okay. I'd just like to echo what you heard from Al. We certainly saw a good count, a very smooth one with really only minor problems that obviously didn't even require any use of any of the hold times. The As far as the propulsion systems that we at Marshall are responsible for, all the engine parameters, the turbine speeds, the turbine temps, all look very good, very, very nominal. We've got a number of this data in real time, and as you heard from Al, we've only had time to evaluate just that data that we get literally in real time as the test is running. And those all looked very good. All of the instrumentation system on both the tank, the solid rocket booster, looked very good. All of it was nominal, and we saw absolutely no problems with any of that data. We did send the ICE team out to inspect the tank. In this particular test, we do run a proof test on the insulation on the external tank and take it above the flight load to prove the integrity of that system for the launch. The inspection showed no anomalies that we can see at this time. We obviously have not had a chance to review all the photographic data, but all of the on-site data that we looked at when a team was out there looks very good. We will be going into the engines over the weekend and early part of next week and doing a more detailed inspection not only of the data but also of the hardware to then ascertain if there's anything that needs to be done prior to the launch. So as you heard from Al, we're very pleased with not only countdown but the performance of all our hardware, and we see no reason that we shouldn't be ready to support the launch.
Thank you. We're ready for questions now here at KSC, and then we'll go to other centers. Are there any questions? Gary Balanoff from Channel 6.
I'm not sure how much you've had a chance to look at the launch crawler transporter launch vehicle, it being a new one for the space shuttle use. Did you notice any kind of results yet from damage of that, or was there any damage to it?
The team they've not gone out yet, but I would not anticipate any problems because of the SSME firings. The SRBs give us more of a problem than the SSMEs do. I wouldn't expect a problem.
Howard Benedict.
Could you list the major milestones you have to go through between now and the next launch? And do you think it does look good for a January 27th launch now?
Well, let me go through sort of some of the milestones. I went through them yesterday, but I'd be glad to go over them again. We will be in our inspection, as Jim said, starting this weekend, and that will be completed by Wednesday noon of next week. And also on Wednesday, we plan to run that portion of the shuttle interface test that we had deferred from the VAB. That will be on Wednesday. And the inspection will continue on through Thursday, and we'll pick up after the new year. Now, on the 27th of December, right after the holiday weekend, the cargo will arrive at the pad, the TDRS IUS, and they will do a week's worth of standalone testing in the PCR. And they will load hypers on the 3rd of January, and we'll begin the installation of the cargo into the orbiter on January 8th. The week of January 10th will be primarily interface tests between the orbiter and the cargo. We'll running tests with Houston, so on, during that week. And we'll do our terminal count demonstration test, which is the equivalent of the old countdown demonstration test with the flight crew to establish timelines, and that is scheduled for January 10th. Now, after that point in time, on the 13th of January, we'll begin our countdown preps. Now, the actual launch date will be established by headquarters, I would expect, in the middle of next week after all the reports are received on the engine firing today. And I would not expect that to be any earlier than the 27th, and it may be some days later. But we'll have to wait and see what comes out of the management meetings on that subject. That basically is our test schedule between now and launch.
What could maybe put several days later beyond January 27th?
Well, there's a couple of things that we always have to look at. It's not just when we'll be ready. There's other parts of the program that have to support, obviously, the flight crew and so on. And also, it's a judgment of how much contingency time we would like to put in the schedule to assure ourselves that we get off on the date we predict. We don't like to select a launch date and then have to slip it. So that's a management decision that will have to be made in a few days. Also, we have a lot of work to do in the crew compartment, work that we deferred from the OPF. We're scheduling that and laying that out in greater detail at this time to see whether or not we can fit all that work in and still support the TCDT that's coming up. So there's some work to be done, some information to be gathered before a launch date is decided upon by headquarters.
Okay, are there any additional questions here? If not, we'll go to Marshall for questions.
Dave Dooling, the Huntsville Times. For either Al or Jim, have you gotten any kind of a measurement of the twang, how much twang there was when you did the firing? It seemed like there was a little bit less than on Columbia.
Could you repeat that question, please? We were getting it very low.
Can you hear me now?
Yes.
Okay, this is Dave Dooling with the Huntsville Times. Al, has anybody been able to measure yet how much twang there was when you fired? It seemed like maybe there was a little bit less.
I was asking Jim. I did not hear. Jim, have you heard?
Yeah, we haven't had a chance to measure it yet, Dave. We would have to do that from the photographic coverage. We would expect it to be just a few inches, probably more, but that's has not been confirmed yet.
Would that be because the tank is lighter?
That's correct. That's
okay,
correct.
And can you give us some percentage measurement of how much of the main propellant load was used up in the firing?
I would imagine, and I'm just kind of computing this mentally, Dave, but I would imagine it'd be about 50,000 pounds out of the roughly 1.5 million. It's really not very much.
Okay, and Al, what kind of work is it that remains to be done in the crew compartment?
Well, we had a lot of work just finishing the crew compartment up. You know, it came, when it came last summer, we had a lot of work to be done before we launched. And we rolled out of the OPF with the intention of getting the FRF off before Christmas, and we deferred a lot of the work we would normally do in the OPF on a new bird to the pad. And it's just finishing up mods that have been open since last summer. It's crew preferences, Velcro installation, foot restraints. We have 200 decals to install for the flight crew. It's just a grouping of work that has to be done, and we're manpower limited in the crew compartment. We can only put just a few people in there to work, so we can't overman it, so to speak. So we have to lay the work out so it can be done by a small crew, 3 or 4 techs at a time. That's what takes the time, and that's what we're laying out now to try to get a real good handle on.
Are there any flight systems or controls lacking or requiring maintenance in there?
No, it's just routine getting ready for the first flight. We'll see this probably again on 103 as we did on 102. It's just finishing up all the work to get it flight worthy.
Okay, thank you. No further from Marshall.
Hey, thank you. Are there any additional questions here? Did you have any more information that you wanted?
Yeah, that number that that Dave was asking for is about 60,000 pounds out of roughly the 1.5 million.
That's pretty good. Remember, for those of you who don't attend all of the time, whenever Mr. Odom says nominal, he means perfect or normal. Okay, thank you all for coming. We'll be seeing you at the launch.